Okay, so here we have a base number problem. So before we get into maybe base the problem, so let me just give you a quick background about the base. Like we use base 10 usually, which is like only digits are allowed to use like 0 through 9. If you use base 5, 0 through 4, if you use base 21, then the numbers are gonna digits are gonna be just 0 through 20 and something like that. Okay. So like for example, if you have 2, 4, 5, which is when you have a number that does indicate the base, that means that's base 10. We just write this number as 2 times 10 to the second power, which is 100, and 4 times 10 to the first plus, and 5 times 10 to the 0 power. But this is base 10, okay? For example, if you have 23.41, and you can write this as 2 times 10 to the first power, because this is ones digit, this is 10th digit, okay? And then that would be 3 times 10 to the 0th power. But since we have some digit after decimal point, so we can write still, that would be 10 to the negative first power, and that would be 1 times 10 to the negative second power. So this is what we do if you want to write any number in terms of its the place value of that each digit, okay? And that's what we have. But if you have something other than base 10, like in this case is base B, we can use the same idea, okay? There's no difference, okay? I'm gonna write that first. So you can do this problem slightly like quickly in a different way, but I'm gonna use the um, geometric series approach. I hope that will help you to remember that as well. So let me start expanding this guy. So our first number R is 0.57, and 57 is repeating in base B, right? So which can be written as 5 times B to the negative first plus 7 times B to the negative second. And since that 57 will repeat forever, so maybe I should have written that before. So that would be 5, 7, 5, 7, 5, 7. So you can continue this forever, okay? So if you keep doing this, that would be 5 times B to the negative third, 7 times B to the negative fourth. And you can keep writing those, all these repeating part. But when you look at these numbers, I'm gonna look into these values and see if I maybe find this some a bit differently. Okay, so usually when you are dealing with the repeating decimals, it's better to multiply this number by like some power of tens, okay, in base 10, so we can cancel when we subtract them, which is what we usually use when we are dealing with the repeating decimal. But now I'm gonna use something else, okay? I'm gonna actually group these numbers together with their fives together and sevens together, okay? So let me do that. So the R will be 5 times B to the negative first power, so which can be written 1 over B, and then 5 times B to the third power, which is gonna be 1 over B to the third. Since I don't wanna write all these fives, I'm gonna just pull as a factor. And then if you wanna write the next number will be 5 times B to the negative fifth. So that will be 1 over B to the fifth power. And you can keep writing those, okay? And then plus, and then if you combine those 7, so that should be B to the second power in denominator. So that will be 1 over B to the fourth, which for this guy. And then if you want to keep writing those, 1 over B to the sixth power. Okay, so it will continue. So what I'm going to do now, if you look at these numbers, like this is 1 over B, this is 1 over B to the third power, which is if you multiply this by 1 over B squared, you get this one. If you multiply this by 1 over B squared, you get this one, which means these numbers actually make a geometric series. So we can go ahead and find that sum by using geometric series. But if you are not familiar with some of the background in geometric series, like if you have a sum, okay, let's say we have A plus A times R. A is the first term, R is the common ratio, and the next term is R A times R squared, A times R to the third. And if you keep adding those infinity, okay, this was equal to our first term over 1 minus common ratio. If my R is actually smaller than or smaller than 1. So you can include some negatives as well, like you can say larger than -1 as well. But if your common ratio, the number that you are multiplying to get the next term is smaller than 1, that is gonna be our sum, A over 1 minus R. So again, this is something you wanna remember about the geometric series. If you don't, so maybe it's better to look at that at some point as well, okay? But this is a background for the geometric sequence series. So now, if you wanna find this guy, our first term is 1 over B, okay? So 1 over B over 1 minus common ratio. Common ratio, as I said right here, 1 over B squared. So that will be that. And then you might be asking, how do I know R is less than 1? Because we know base B, and then B is given as a digit. So it has to be at least 8, because I had 5 and 7 in my number. So my base should be larger than those digits. So B is a positive integer, which is larger than 7. If you divide 1 by a B, so that is going to be lesser than 1 for sure. So we know this sum is going to be equal to 1 A over, like first term over 1 minus R, okay? And then that was multiplied by 5. And the same thing with this guy. So 7 times 1 over B squared over for this piece. And 1 minus, the common ratio is the same thing, 1 over B squared. So if you go ahead and simplify this a bit, I guess it will be helpful. So you can 1 over B times this guy, so 5 over B. So this denominator can be written B squared minus 1 over B squared. So if you multiply this with the first fraction, so you can write this way. And the second one is the similar, so 7 over B squared times B squared over B squared minus 1. So one of these B's will cancel, these guys will cancel, and that is 5 plus 7B, right? Over B squared minus 1. So at this point, yeah, we can leave it as it is, okay? So we got the only one of these numbers. And then I'm gonna use the same idea, okay, similar to this one. I'm gonna expand the second one, but I'm gonna split this one first, okay? So 3R can be written 1 plus 0.6. 0.6 is repeating, so I can write 0.06, 06, 06, and you can continue forever. Since we have only one digit that we need to think about, because 0 doesn't add up anything, just 0, so that will be a bit less work than this one. So that could be written as 1 plus, so you have like 6 times, so our like base was B still, so that should be B to the negative first power, negative second power, plus 6 times B to the negative 4, and 6 times B to the negative 6, and you can continue those. So that is equal to 1 plus 6, I can pull those, 1 over B squared, okay, 1 over B to the 4, 1 over B to the 6, and you can continue forever. Again, this is also similar to the same idea of the geometric series right here. So let me write those. So 1 plus 6. So our first term is this guy, so 1 over B squared. This divided by 1 minus common ratio, so common ratio 1 over B squared, and that is 1 plus 6 over B squared times, if you simplify this guy, that will be B squared minus 1 over B squared over B squared minus 1. These guys will cancel. Okay, and then I have 6 over something plus 1. So 1 plus 6 over B squared 1 and B squared minus 1. So if you simplify this, that is B squared minus 1 plus 6, which is going to be plus 5 over B squared minus 1. So this is something that is equal to 3R. And this was just R, okay? And then if you multiply the, maybe this r by 3, so you do get 15 plus 21b over b squared minus r equals b squared plus 5 over b squared minus 1. So these guys will cancel. So if you want to pull everything one side, so that will be minus 21b. Okay, and then is it 21b? Let me double check that part. We had the b squared plus 5. Let me see that part. Okay, and then I need to multiply this by 3. That's gonna be, okay, b squared plus 5. Okay, I don't want to mess up because I don't want to go everything one more time. So we got 5b. Actually, this was actually wrong, right? So this was 7 over b squared minus 1. And then this part was 5b. Okay, so this is wrong. Okay, let me fix that. Okay, so I messed up a bit. So this was 5b plus 7 over b squared minus 1. Okay, so now if I multiply this r by 3, so you got 15b plus 21 over b squared minus 1, and that is equal to our 3r, which is b squared plus 5 over b squared minus 1. Since denominators will cancel each other, so you get b squared, subtract 15b from both sides, and then subtract 21 from both sides. So that should be equal to 0, which is really nice because this is factorable. So that's b minus 16 and b plus 1 equals 0. So because if you multiply minus 1, this like negative 16 by 1, you got this guy. If you add negative 16 and 1, you got negative 15, which is okay. So if the product is 0, b is 16 or minus 1, right? But negative 1 cannot be answered because that was our base. So base has to be 16 because we know that's going to be larger than 7 at least. But the question was asking r, which is, okay, we are almost there. So as soon as we got b as 16, you know, we are looking for r is equal to this guy. So you can just go ahead and plug this 5, 16 plus 7 over 16 squared minus 1. That's 87 over, this is 256 minus 1, 255. And you want to really make sure that is still can be simplified. So 87 is not a prime number, so we can divide by 3 because this is divisible by 3, and then that's also divisible by 3. So that's 29 over 85. Okay, so that was a really nice question, to be honest. And I guess I just used the geometric series to get what I want. But again, if you really go with the base number approach, so this question can be done slightly better way. So which is I'm gonna ask you to challenge yourself and see if you can do this problem in a different way. Okay. So, but this is it for now. I'll see you in next video.